Oh, well. Anyway, let's keep going. So here we're going to use the least common multiple. Essentially, if you have fractions like this, okay, what you want to do is eliminate those fractions. You have to eliminate them algebraically. And one way to do that is to use the least common multiple. In other words, you find the least common multiple of the distinct denominators. So in this case, we have 3, 4, and 6, right? Of those three denominators, right? I mean, technically 1 is a denominator, but we can ignore that. We have 3, 4, and 6. We want the least common multiple. And so by listing them, you have 3 times 1, which is 3, 3 times 2 is 6, 3 times 3 is 9, and so on. If you do that for 3, 4, and 6, we get 12 is the least common multiple. Right? It's the first positive number in all three lists. Okay, now what do we do with the 12, which is the least common multiple? As you can see here, we're going to multiply both sides by 12. Now, why does that help us? Well, look what's happening. When we distribute, right? So we're multiplying both sides by the same non-zero number, in this case 12. Now we simplify both sides. So on the left side, we're going to distribute, as you can see. And watch what's going to happen. Well, 12 over 3, what happens here? The 3 is gone, and 12 turns into a 4. Right? 12 is 3 times 4, so the 3's cancel. Here, the 12 just stays there. Here, 1 over 4 times 12, right? 12 over 4, that's the same as 3, because 12 is 4 times 3. So in that case, the 4's would cancel. We're left with 3 here. Here, 12 over 6, right? 12 is 6 times 2. So the 6's will cancel. We get 2. But notice now the denominators are gone. That's good. That's what we want. Now, you're probably thinking, do you have to use the least common multiple? Well, no, you don't. There's other numbers you can use. You could actually multiply 3, 4, and 6 together. You could do that. I mean, the number you'll multiply both sides by will be a lot bigger. But I just thought the least common multiple was a good number to use. So you can also, if you know how, you could also get a common denominator, with the 3 and 4, and then combine that way. So there's more than one way to attack these problems. I just thought the least common multiple would be the easiest. Anyway, let's keep going. Let's solve this. So we have all this. Now, what do? We distribute. So we're going to distribute. As you can see, that's what I'm doing here. 4 times x is 4x. 4 times 4 is 16. 12 times 2x is 24x. We have the 3 here. 2 is distributed. And then, I didn't show everything. Well, I'm not done yet, but we have all this. You can combine like terms, and you get this equation. And this one's a lot easier to solve, right? That's why we manipulate equations. We're trying to get something that's easier to deal with. And here, this is all the other steps. It's just like before. The idea is the same. You want to get x. Wait, oh, sorry. I thought that was a mistake. Okay, you want to get x all alone on one side. And everything else you want to get on the other side. So I brought the 13 over to the other side. That's what's happening here. We have 28x is 6x minus 9. Then the 6x I brought to the other side by subtracting. So we get 22x is negative 9. And then we just divide by 22. Okay. I think it turns out also, if you use the least common multiple, this answer here will be simplified meaning the numerator and denominator will not have common factors except 1. I don't know if that's always true because I haven't proved that myself, but I do want to say it's true. So it could be wrong though. I know that process was a little involved. I understand that. Okay. All right. Are there any questions about that? Now, I can't see the chat here, so speak up if you have questions. If not, I'll keep going. Okay. All right. Let me go through another example. So this one also, okay? So we want to solve this equation. Now, I did say what the least common multiple is already. I should have, I thought this would be hidden. So what we're going to do here is get the least common multiple of only 7 and 3. You only want to find it for the distinct denominators. So in this case, the distinct denominators are 7 and 3, right? So 7, we list the multiples, same thing with 3. And you can see by listing a bunch, you see that the first positive common entry among the multiples is 21. So 21 is the least common multiple of 7 and 3. Again, this is why I think it's easier to do this method, because if you were to multiply all the denominators together, you would have 7 times 7 times 3. That's way too big. At least I think so. Okay? It's not wrong to do it that way, but it's just more work, I think. But anyway, once you get 21, it's just like before, right? That's our least common multiple. And so we multiply both sides by it. And as before, we distribute, right? And then you can see, as before, there's some cancellation. 21 cancels with 7, you get 3 left over. 21 cancels with 3, you get 7 left over. Same thing over here. And once the denominators are gone, then it becomes a lot easier. So we get this. How do we solve this? Just like before, we distribute. We get 6 times x minus 9, 7x minus 7. Here we get 9x. And then again, we just do some basic algebra. For instance, here, we're going to get 6x plus 7x is 13x. Minus 9 minus 7 is minus 16. We have 9x. So you could probably guess what's going to happen next, right?
There's a mistake in the problem.
What'd I do?
In the first step, it says 2 minus 3x, but then in the second step, it goes to 2x minus 3.
Okay. Oh, darn. What should be is the right one? 2 minus 3. Yeah, it should have been 2x minus 3. Sorry about that. Thanks for finding that. So it should have been 2x minus 3, but this is what we get. I'll have to fix that. Okay. And then again, same story. You want to get x all alone. Okay, so I subtracted 13x. I probably could have subtracted 9x, but it's okay. Either way, we get x all alone on one side. Okay. And then we end up getting x is 4. So 4 is our answer. Okay, that's good. So we have that example. Of course, I made a mistake, but hopefully you guys understand what I'm doing. So at least I think we'll have to stop here because we have less than a minute left. Okay, so here, let me pause the